So the topic of this presentation is how we leverage at Orca graphs to answer cybersecurity questions. Now, to give you a heads up, the cybersecurity question we're asking ourselves is actually whether an asset is internet facing or not. So first of all, let's just talk what's in it for you. I mean, what are we going to talk about and what the agenda is going to be. So we'll see how we approach this problem of determining whether a cloud asset is internet facing or not using graph databases. So this is our theme, and this is the question that we're going to answer end to end, including running and writing code. Yeah, okay. So we're also going to talk about cloud and networking. So we set up a cool environment of some private EC2s with a load balancer, Apache web server, and we'll soon see this environment to determine whether those assets are internet facing or not. We're also going to cover graph databases in a very short while. And we're also going to have some hands-on graph database modeling with Python. Okay, so we're going to take the assets that we see in the cloud and we're going to model them with nodes. We're going to model the relationships between the access of those assets with edges. And then finally, we're simply going to write and run an algorithm that determines whether they're internet facing or not. So that's pretty much it. Okay, some buzzwords we're going to hear during this talk, and maybe I have already told them. So we're going to talk about graph databases, cybersecurity, cloud, scale, AWS, Neo4j, what else? BFS, and many other networking concepts and ideas. So just a quick disclosure. I do assume some knowledge in cloud and in some networking. So I'm sorry if you're not familiar with this stuff, but I'm not going to cover them. And I'm just going to show you the lab that I have set up. Okay, so let's take a look at our environment that we're going to explore. Okay, so the environment we're going to explore is going to be a very simple environment of an application. So I have already set up, and I'll show you soon those assets, two EC2 instances on AWS Cloud. And on those EC2 instances, we have an Apache web server running. Okay. Now those EC2 servers, EC2 instances, they are in a private subnet and they are not exposed to the internet right now, and they don't have any public IP or any DNS. So what I also made, I also created an application load balancer, which is going to forward the traffic from the internet to those EC2 instances. Also, I had already set up an internet gateway to handle the traffic to the internet, and also an ad gateway, so those private instances can download the Apache web server and also download it and run it. Anyways, so let's take a look at this environment right now. So if I'll just go to the AWS console, you can see I'm right now in the EC2 dashboard, and I am on the load balancers tab. Okay, so we can see we have here a DNS name. So I'll just go over here and put this link, and we can see as I refresh it, every time we're getting and hitting a second EC2. First is the first EC2, then the second. So the load balancer is actually balancing the traffic for those private EC2s. If I'll go to the instances, we can see that we have two EC2s, and we can even see that those EC2s, I'm not sure that you can see my mouse, but those EC2s don't have any public IP addresses, nor they have public DNS. So they are actually private, and we also have attached also, and I also prepared all the security groups and all the networking to let them accept HTTP traffic from the internet. Okay, so I don't want to go and dive into the entire networking issue over here, because our goal in this talk is to determine whether they're internet facing or not using Python. Okay, just a quick note, I'll just show you over here. I'll go to the VPC. and I'll show you that they are in private subnets. Okay, so I created two subnets for those EC2 instances. Created also two public subnets, and this basically enables our application to be fault tolerant. So if one instance fails, then the load balancer will balance the traffic to them. Okay, so now that we have covered this environment, okay, I'll just show you again this picture. Then the question that we are asking ourselves is, how do we determine with Python that they are internet facing? Okay, but before we do that, let's talk just a bit about myself. Like Kayla introduced me, my name is Eden Marco. I was born in LA, raised in Israel, married, 29 years old, software engineer at Orca Security for almost 2 years now. I have a BSc in computer science from the Technion, Israel Institute of Technology. Also a teaching assistant at Reichman University for 2 courses, functional programming and intro to CS. And also Udemy bestseller instructor. So I have mainly 2 courses. Those courses are about, one is Neo4j and Cipher query language, which is also a graph database. In this course, I quickly demonstrate how to use Game of Thrones data. Okay, I download a data set of Game of Thrones, and I simply show how to use the Cipher query language to induce some cool conclusions about the show. So this is one course, and the other course is about Pytest and about Django applications and how to test Django applications. Okay, so where do I work? And I work at Orca Security. And basically, it started like this in Israel. This is the Israeli team. Then became like this. Here, I joined in the middle. Then became this. And then this. Okay, so basically, Orca in a nutshell, founded at 2018. We have 8 founders, which are very technical, hands-on, raised in total 550 million. And we're currently around 200 employees. 105 are in the engineering team, and maybe even more. I just stopped counting. And we have also many sites for our engineering team. We have a site in Israel, which is where I am located, and we have a site in Minsk, where are you at, I believe. And we have also a site in the UK, US, and many other sites that I don't know of. Also hundreds of customers, but that's Orca in a nutshell. So what do we do? I mentioned internet facing, cloud assets. So basically, we at Orca, we provide a security solution, a holistic security solution for the cloud. We allow our customers to inspect and to have the posture and to see how secure their cloud assets are. And how we do it is by modeling everything like a graph. And when we do that, we can determine whether an asset which has a vulnerability on it, whether we are able to give context and to prioritize those vulnerabilities and those CVEs by giving this context, let's say if it's internet facing or not, if it can access other assets, like you can see in this example, which it can access this EC2. And this EC2 can access this DB with a PII, private information. So basically, if this asset is at risk, then this whole chain is at risk. So that's basically what we did at Orca, and it's very relevant to our talk right now and to our demonstration of to determine internet facing or not. Because of course, if an asset will be internet facing, then we'd want to give the alert that we issue on it a higher score. Anyways, okay, so we discussed a bit about Orca. So let's see how we can calculate whether this asset is internet facing or not. So first of all, let's talk about what's internet facing, because this is a broad topic. Now, this question is a bit obscure, because if you'll ask this question different people, you get different answers. But for simplification and to simplify this talk and this POC I'm going to show you, let's assume that an asset is internet facing if it can accept traffic, let's say with the curl command. So like I showed you before, we could have gone to this we could have curled to this asset and get the response as well. I want to do it now just because I just want to save in time. And yeah, that's it. So let's discuss how we would do it. Okay, so there are a couple of approaches to do this. Now let's go back, at least for me. I mean, using with relational databases is the intuitive thing to do. I mean, to create tables, to create models, let's say in Django and with Python, and to link them one with another, maybe a foreign key. But when determining if an asset is internet facing or not, in this case, if we have many assets and we have a very interconnected environment, and this is exactly how we profile cloud environments. They are very and highly interconnected. So this, if we do this using relational databases, will result in huge queries with a lot of joins, and really, it's not very pleasant. So what we want to do is we want to approach this problem as a graph theory problem. Okay, so graph theory in 2 seconds. Okay, I assume I assume that you're already familiar with it, but just for the sake of it, a graph is a set of vertices and edges. Maybe I'll call them the vertices nodes. You see those circle ones are nodes, and this arrow over here connecting to two nodes is an edge. Okay, and what we're going to do now is going to model our internet-facing assets, and we're going to run the algorithm. But before that, let's say I want to show you and tell you what are we using here at Orca. We use AWS and Neptune as our graph database. The reason we chose it because it's fully managed, because we are native to AWS. That's where we deploy the production. That's where we develop. It also supports multi-tenancy with its partition feature. So it allows us also to retrieve with the same partitions information in a very short time. And also, it's very high performance with all the optimization AWS engineers have put in to this service. Okay, but this talk is not about Neptune. Okay, and we're going to use for this talk Apache Tinkerpop and Gremlin. So basically, Apache Tinkerpop is the framework that we will be querying now our graph and our graph database, and Gremlin is going to be the traversal language. Okay, so like Cypher has, if you're familiar with Cypher and Neo4j, like Neo4j has Cypher, then we're going to use Gremlin over our Neptune DB. So let's now discuss the algorithm and what we're going to do. So the first thing we want to do is to scrape the cloud metadata from AWS. We call that the control plane. Okay, we want to go and we want to execute AWS commands to get all the EC2 instances, all the security groups, all the load balancer, and then we want to model everything together in our graph as nodes and edges. And the third thing will be to simply run a BFS. Okay, so what you can see right now in my presentation is a simple command of AWS EC2 describe instances, which returns the list of instances. This is the AWS CLI. Then we will model it into a graph, and then we'll simply run an algorithm that will output all the paths from the internet to those assets. Okay. So just to show you that I have set up everything. So right now, if I'll just let's just run everything, just show you the script I made. I'm going to show you the code very soon. Okay, and I'll just run it again. Yeah, I had to do a little bit setup just for the talk. Okay, so here we got an output, okay, of our algorithm. And basically, this output will show us those. It will iterate over all the EC2 instances, and it will give us the path that the internet can access them. Okay, so you can see for the first EC2, we can start from the internet, then go through this load balancer I created, and then the traffic will go to this instance. Okay, so let's go back to the presentation, and and let's dive into the code. Now, just another disclaimer over here. What I'm showing you is not the cleanest code, and it was only written as a POC. It has a lot of simplification for the talk, because obviously we can't cover everything in 45 minutes, but it does contain everything end to end. Okay, so we'll have a POC solution. Okay, so this is our main Python. Code. Okay, our main function. And we can see at the beginning, we are getting all the information for AWS. We have here get instances data. We have here a function called get load balancers data. And we have here get target group, okay, which will get us all the target groups of this. Then what we will do, the second part, will be to simply model everything like a graph, okay? So you'll see here, I created the internet. We'll create the EC2 nodes. We'll create the ALB. We'll create the connections between the ALB to EC2, and we'll cover everything. The third thing we're going to do is we're going to run an algorithm which is going to determine whether there is a path from the internet and to those instances. Okay, so let's first start with the first part of parsing, okay? And parsing the information, getting the control plane. So basically the code that I have right here, I'll show you right now. So basically this code is very, very simple. What it does, it uses the botter3 library with Python, uses its clients. For example, let's talk in the beginning. Let's talk about instances. It simply makes a request through the EC2 client to describe the instances and gets a result. What we do with this result? We simply manipulate it and maybe clean it and to have something to work with. Okay, so I'll show you an example for what do we get from this command. So this command actually describe instances. It's going to be the same command as I'm writing right here in the AWS CLI, and this is how the output will look. Okay, we can see, for example, we got a list over here, and our instances. We can see the private DNS, private IP. Maybe we can see also tags. We can see all the information about the EC2 instance. Okay, let's return back to the presentation. Amazing. Okay, so right over here, we describe the instances data, and we do the same for the load balancers, okay, which we will get the application load balancer. Now, for this talk, I have only made and wrote the ALB, and I'm not going to talk about other load balancers, network load balancers, not going to talk about them, just about the application load balancer. And the third is the target groups, okay? Also the target groups, but this part of the code is not the part that we're interested in, because it's simply parsing the code, getting the results from AWS, then parsing and cleaning the code. Anyways, so we have discussed this part over here, okay, this part of our main function, which gets all the metadata from the cloud, the control plane. So basically, this gives us this part of the chain. Now, what we want to do is we want to model everything as nodes and edges, okay? So that's what we want to do. We want to take this information that we see over here, and we want now to transfer it to nodes and edges in some kind of graph. Okay, so for that we want to go from this, as if we take a look at this as our environment, we want to turn it into this. Okay, and this is our Gremlin visualizer. Okay, so this is an open source code that will help us connect to our graph database and see all our nodes and edges. So if I just open something I have already prepared, so you can see right now our environment in this visualizer. If you'll just, I'll just click on one of them, we can see all the information of this EC2 that I clicked on it. We can even play with it. For example, if I want to display, instead of this, I want to display the instance ID. So I can do something like this. I can say, hey, the labeled field will be instance ID. Let's refresh it, and now we see now the instance ID. And let's say instead of this ALB to show us IPv4 and the address type, I wanted to show the load balancer name. Oh, okay, called it OTS ALB. Okay, so this is a node, a dummy node that we created that represents the internet. Okay, so you can see that we modeled here an edge between the internet of ODS to OTS ALB, and this edge is labeled as forwarding traffic. Okay, if we'll click on it, let's just click on this edge, then we can see that the listen port of this load balancer is going to be 80. Anyways, let's go back to the code and see how it's done. Cool. Okay. So now, okay. So now we can see at the beginning, we are creating an internet node. So what this syntax over here, for those of you who are not familiar with Gremlin, Gremlin is the traversal language we're going to use. And it's very easy and intuitive to figure out. So here we're starting with our graph, and we're adding a vertex, and we're going to label it as internet. We're going to label it as an internet, and then we want to give it a property of ID internet. Now, why do we give it an ID and not use the generated one that Gremlin is going to give us? Simply because we want to access it later on easily. So we want to then maybe filter out for all those all those nodes that has the ID of internet, and from them we will start looking for our instances that we're connected to. So let's take a look at the code that models everything like a graph. So right here at the beginning, we are creating the EC2 instances. So we got the instances through the Boto3 library, and now we're simply iterating over there and creating a vertex that is labeled as an EC2, and with the property of the ID to be instance ID, just like we did with the internet. The next thing we want to do is you want to add all the properties of this EC2 to that node. So for that, I just wrote and implemented the function that would iterate through all the properties that we have and we got, and we'll simply add them to the EC2. Okay. And now what we want to do is we want to create the ALB nodes. Okay, so we're going to go through all the application load balancers. We're going to create an ALB node, and we also, the same way, we will use and add the properties to that node. And if we had time, and this is what we do in the real solution, we would also look at security groups. We would also look at NACLs, maybe at route tables. So we will do a lot of things before connecting these load balancers to the internet. Okay. However, because we don't have time to do this, I'm just going to assume that everything has access. Okay, so I'm going to add right over here. I'm going to add here a node, an edge between the internet. You see, we're starting from the internet, then we're adding an edge, which we're going to label as forwarding traffic to this load balancer, and we're going to give it, for example, the listener port of 80. Okay. Now, yes, this is a dummy lab, so obviously this is not the robust solution. Okay, this is just for the POC of the stock. Okay, so right now we basically labeled and created our ALBs and our instances. So now what we want to do is to connect them one with each other. Okay, so for that, what we'll need to do is we'll need to find all the target groups of those load balancers, and we would want to check if those instances are part of those target groups. And if they are, we do want to connect them with the ALB. So this is basically what we're doing. We're doing in this code. So you can see right over here, I'm getting all the target groups in this ALV. I'm taking and iterating through all the target groups, and then I'm taking only the ALB that I'm interested in. Then I'm going to get this node of this ALB, and then I'm going to go through the target groups and see if there is a connection between them. I'm going to create it. If there is a connection between the load balancer to the EC2, I'm going to create an edge. I'm going to put it as forwarding traffic, and then I'm going to give it the property of the port. Again, everything is going to be through the AWS information we got through the control plane. Okay, so basically now we have created this graph, okay, that I showed you before. So let's just take a look at it again. Okay, so we can see that we have the internet, it's forwarding traffic, and we can see now those edges between the ALB, okay? And we can see that, let's take a look at this edge. We can see that it's forwarding on port 80, and it's going to get to this instance over here, that we have all this information. So let's go back to the presentation. Okay, so we're almost there, okay? We did and we modeled everything together. Now the last thing we want to do is to simply find any paths from the node internet to those load balancers, okay? So for that, what we want to do is we'll start with our graph, okay? And we want to use a BFS method of going through the graph, okay? This is called traversing, okay? We're going to traverse through our graph. So we're going to get all the nodes in our graph, but we want to start from the node, yeah. We were here, yeah. Okay, so we started with our graph. We said we want to iterate through a BFS method. We took all the vertices, and now we are starting to find the node with this source ID. Now, when we call this function, shortest path, I remind you, we call it with the source ID of the internet, as you can see here, and the target ID for each instance ID. Okay, for here, you can see we're iterating through all the instances. Okay, we're iterating through all the instances and getting all the shortest paths. Okay. Now, why are we getting the shortest path and not all the paths? Because we only care if there is a path or not. We don't care about the path yet, at least in this POC solution. Now, this value map simply gets simply a function of Gremlin that gives us the instance ID. Okay, so we are starting from our source ID. Okay, this is where we are starting our traversal. Then we're using the repeat command, which is pretty intuitive, that it repeats our next step. And we want to see all the outgoing edges that has the label forwarding traffic, like we had before. And we want to use something which is called simple path. This basically filters out any cycles and any nodes and edges that we already saw, so we won't get into an infinite loop. And then how do we want to iterate through everything? We want to do it with until we get the target ID, which in our case, the target ID will be those EC2 instances. And that's it. At the end, we want to turn it into a path. This is simply manipulating the data from Gremlin. Maybe we want to limit the path to get only the 10 shortest paths, and we want to turn it into a list. And then this code, right over here simply prettifies everything. Okay, simply prettifies everything, and that's basically it. Okay, so what did we do in this talk, and what did we talk about? We talk about cloud. I showed you the cool lab environment that we made. We showed you a bit about the networking, the security groups, the ALB. We talked about graph database in a very short while, and then we hands-on modeled nodes and edges in our graph, and then ran the algorithm ran the algorithm to determine whether they're internet facing or not. Now, this determination if an asset is internet facing or not is super important to give the context how vulnerable it is, and if it has vulnerabilities, if they are any interest to us. Because if we have an asset that, for example, has a vulnerability on it, however, it's not even exposed to the internet and no one can reach him, then it's not very interesting. So we don't want to issue that of a severe alert as an asset which is internet facing, so anyone in the internet can access it and can actually exploit this vulnerability. So that's basically it. If you have any questions, I'll be happy to answer.
Yeah, thanks, Eden. Let's wait for a while people type in and thinking about questions, because your talk is rather intense and many information. Please, Nikolai, maybe you have any question?
Oh, not
By the way,
for now.
By the way, if you want to contact me, you can add me on LinkedIn. I'd be happy to talk and get to know you. So yeah.
Mm-hmm. I will drop a link in chat with your LinkedIn profile. Yep, we have a question. Well, but it concerns Udemy. You mentioned Udemy. How much time does it take to create a course?
Okay. So it depends how much are you experienced with editing videos and how much time do you want to put into it. But basically, maybe because I'm a bit experienced with creating videos, then the rule of thumb will be maybe for every 1 minute of content, then it takes around 20 minutes of content of time. Sorry, 20 minutes to produce, because there's a lot of things to address. The microphone, recording the screen, then editing, then creating the content and everything.
Mm-hmm. Another question is regarding the system that you've shown. How do you test it all?
That's a good question. So basically, because we are using cloud environments and they are by nature ephemeral and they're changing all the time, then what we can do is, first of all, is to unit test it, and that is to fake and to make and create stabs of the output we're going to get from the cloud providers, and then rely on them. But so that would be one solution, to simply mock the cloud responses. We can do that easily with a Python library, which is called Moto. And if we want to make a more end-to-end test, then we'll need to deploy the assets like I did and make them, for example, internet-facing, and we would need to actually run on those test accounts. Let's call them. Yeah. So I see there is. Could you share the presentation after the event? Yeah, sure, no problem.
Mm-hmm. I believe Eden will drop the presentation to organizers, and organizers will send an email with presentation attached.
Yeah, sure.
Cool.
Mm-hmm. Any more questions? Nope. Eden, thank you very much then. Guys, you can add Eden on LinkedIn.
Yeah. Nice meeting you all.
Nice meeting you. Thank you very much.
Thank you, Eden.
Thank you. Bye-bye.